Hi, in this video we will see that it is possible that two or more compounds can have the same formula. When you have two different compounds that have the same formula, these are known as isomers. Now, in the last video we saw that there's only one compound of formula CH4, only one that's ever been discovered to exist. It is called methane, and it turns out, as we've seen, there's only one way of attaching one carbon and four hydrogens, and thus one way of drawing them. And you might remember that rotating the structure does not make it a new way of drawing. So again, the theory that this is the structure of methane fits with the fact that there's only one compound of formula CH4 that's been discovered in the world. Similarly, there's only one compound of formula C2H6. It's called ethane, and there's only one way of attaching two carbons and six hydrogens, and that's and again, remember, rotating it, drawing the angles differently, and so on doesn't make it a new way of drawing it. So again, only one way to draw matches with the fact that there's only one ethane that's ever been discovered in the world. Similarly, only one compound of formula C3H8. It's called propane, and as we've seen, there's only one way of attaching three carbons and eight hydrogens. That's only one way to draw the structure. Again, remember, rotating it, drawing it around a corner, or drawing different angles doesn't make it a new way of drawing it. However, you might ask, what about drawing it in a ring? Can we attach three carbons to each other in that way? And the answer is yes, it's certainly possible. In fact, it exists in the world, but let's go ahead and add hydrogens. So the formula is what? C3H6. Not the same as C3H8, so it's not an isomer of propane. It exists. It's called cyclopropane. It has different properties than propane because it is a different compound, but it's not considered to be an isomer. Now we will consider cyclic compounds later, but for now just remember cyclic alkanes can never be isomers of non-cyclic alkanes. So let's consider some more non-cyclic alkanes, specifically for carbons. I've drawn four carbons in a row. How many hydrogens would it have? Well, let's go ahead and put enough bonds in so that each carbon has four bonds. And when we go ahead and add the hydrogens, we see that the formula is what? C4H10. As it turns out, there is a compound with this structure and the formula C4H10. It's called butane. It's the stuff that you find in your butane lighter. Now pause the video and see if you can draw four carbons in a fundamentally different arrangement than four in a row. Did you draw a ring like this? Or like this? Now those are both perfectly fine ways of arranging four carbons, but it turns out that if they won't have the formula C4H10, they will have a different formula. So they can't be isomers. As we said before, cyclic alkanes cannot be isomers of non-cyclic alkanes. How about, though, if we arrange the four carbons like this? If we add the hydrogens, we get a formula of C4H10. So is this a different compound? Let's take a look at some models and see. Notice that this one is like the top one, four carbons in a row, and indeed has 10 hydrogens as shown in the structure. This one is a model of the second structure, and notice that it also has four carbons but arranged in a different skeleton than this one. Notice that the hydrogens are attached in different ways to the hydrogens. Hydrogens are attached in a different way to the carbons, so therefore it's not the same compound. Turns out that this is a compound called isobutane, and it has different properties than the butane drawn above. Thus, these are in fact isomers. Two different compounds with the same formula. Now, can you draw five carbons, not in any sort of ring, but just five carbons, and how many different ways can you do it? And see if you get the same number of hydrogens for each of the structures that you can draw. I'll give you a hint. There are three ways of drawing five carbons. Thanks for watching. Bye.